Hello everyone, welcome to the traditional math sanctuary. If you're new to this, please subscribe. Oh guys, if you check out my previous video, we were able to evaluate the limit as x approaches 0 of this trigonometric function, right? So we were able to implement the fundamental trigonometric limit, which is limit as x approaches 0 of sine of theta over theta equal 1, and that is true for the inverse as well, right? And we were able to determine that the final answer of this particular limit is equal to 25 over 49, right? And we were able to demonstrate it only using the fundamental trigonometric limit. So today, let's try to find the same limit using L'Hopital's rule, right? Which is written here, L'Hopital's rule, right? So that is a different method of evaluating this particular limit. So you can either use the fundamental trig limit, or you can just go ahead and use L'Hopital's rules. Okay, so what does L'Hopital's rule say? Well, L'Hopital's rule says if you have an undetermined form, which means when we plug in 0, let me use a sharper pencil, limit as x approaches 0 of sine square, let's plug in a 0, so that's going to be sine squared of 0 over sine square of this was 0, because 5 times 0 is 0, of sine squared of 0, that's going to be 0 over 0, which is an undetermined form. So now we can apply L'Hopital's rule, which says limit as x approaches 0 of f of x over g of x equal limit. Well, by the way, the general L'Hopital's rule form is limit as x approaches a certain number c, which is 0 in this case, right, equal the limit as x approaches the same number c of f prime of x over g prime of x, right, which simply means their derivatives. All right, so we're gonna go ahead and implement the same rule, right? So we're going to try to find a derivative of our overall trig function, right? So that's going to be a limit as x approaches 0 of the derivatives sine square of 5x, their derivative, right, over the derivative of sine square of 7x. Right. Now, to avoid any sort of confusion, let's try to evaluate their derivatives separately, right? Let's start with the numerator, right? What is the derivative of sine square of 5x? Remember, guys, this is a composite function, right? Which means a function within a function, right? 5x is a function of its own, and sine of x is a function of its own. So we're gonna go ahead and apply the chain rules, right? And also this trig function is in the form u to the power n, right? Applying the chain rule, that's gonna be finding the derivative is gonna be n u prime, right, which is the derivative of sine of 5x, u to the power n minus 1. Right, so we're gonna apply the same rules. So let's start with the n. Our n is 2, right? Because sine squared of 5x, that's the same thing as sine of 5x squared, right? So n, which is r2, and then u prime, which is the derivative of sine 5x. Well, this is where we also apply the chain rule. So that's gonna be the derivative of 5x, which is 5, and then derivative of sine of x, which is cos of x. Then you replace the x by the 5x, so that's going to be 5 cos of 5x. That's the derivative of sine of 5x, right? And then u to the power n minus 1, which is simply sine of 5x to the power 2 minus 1, right? So our final answer is going to be 2 times 5, we can multiply these two together, right? Cos of 5x, sine of 5x, right? That's for the numerator only, right? That is for the numerator. Right? Now let's do the same for the denominator, right? So derivative of sine squared of 7x is going to be Rn, which is the 2, and then derivative of sine of 7x, that is simply cos of 7x, right? And then sine 7x, right? So that's it, and now we can just go ahead and rewrite our whole expression, which is limit as x approaches 0. Now let's replace the numerator by its value, right, and the denominator by its value. So the numerator is simply 10 cos of 5x sine of 5x over the denominator, which is 2 times 7, that's 14, cos of 7x sine of 7x. Now remember, guys, right, since we have a cosine and a sine, if we plug in the 0 in this particular expression, we'll be back to our undetermined form, right? So which means we can use L'Hopital's rule once again. So L'Hopital's rule give us the chance to go one step further, which is we can also find limit as x approaches c of f second prime of x over g second prime of x, right? Which is finding the derivative one step further. But before we go ahead and do that, I wanted to implement a very important trigonometric identity, right? Sine of 2a and cos of 2a. What does sine of 2a says? Sine of 2a equal, according to our trigonometric identity, sine of 2a is equal to 2 cos of a sine of a, right? In this particular example, if we use the numerator, for example, that is equal to 2 cos of 5x sine of 5x, right? So we can go ahead and replace that. So all we need to find is what is our sine 2a, where that is simple. That's going to be sine of 2 times RA is obviously 5, so the 2 times 5, which is sine of 10 equal to cos of 5x sine of 5x. Correct? That is very important, this trigonometric identity, right? Let's do the same for sine of the denominator, right? Let's do the same for the denominator, right? RA is going to be 7x, so it's going to be 7 of 2, sine of 2 times 7 equal to, same thing, 2 cos of 7x sine of 7x, right? Another one, very important, right? So let's plug that back to our limit, rearrange everything, right? We're gonna have limit as x approaches 0. Now pull 2 cosine of 5x sine of 5x out of this expression, so we're gonna be left with 5, because 10 equals 5 times 2, so 5 outside. And then we could just go ahead and replace this expression by sine of this expression, right? I'm sorry, this one, right? So it's gonna be sine of 2 times 5, which is simply 10. And we're gonna do the same for the denominator. So now we're gonna pull out the 7 out of the 2 out of the 14, right? So we're gonna have 7 outside, and we have sine of 2 times 7, correct? So this is our final answer, right? But since, again, I keep forgetting. I keep forgetting 5x. Like, it's not just 2 times 5. Like, it's 2 times 5x. RA is 5x. Apologize. I keep forgetting the x. Like, it's not part of it. It's 2 times 5x. So that's 2 times 5x. And then there's 2 times 7x, right? Again, if you plug in a 0, you're gonna be left with an undetermined form, right? Again, so which means we can go one step further, which means evaluating the derivative one step further, right? So let's go ahead and do that. Let's find the derivative once again. Limit as x approaches 0. Now, what is the derivative of 5 sine of 10x, right? Because 2 times 5 is 10, right? Let me rewrite this. The numerator is still 5 of sine of 10x over 7 sine of 14x, right? What is the derivative of 5 sine of 10x? That is simply going to be 5, and then the 10 come outside, 10 cos of 10x, right? Over, same thing here, 7, and then you pull out the 14 cos of 14x, right? Now let's go ahead and simplify. So we got limit as x approaches 0, right? We can simplify by 2, right? 10 and 14, they both divisible by 2, right? So we can simplify by 2 on the numerator and the denominator, so we're left with 5 times 5, right? Times 5 cos of 10x over, if we divide 14 by 2, we're left with another 7, so 7 times 7 cos of 14x, right? And this is simply when we apply the direct limit, which is x equals 0, that is simply going to be equal to 25, I'm sorry. That's going to be 5 times 5, which is simply 25 cos of 0 over 49 cos of 0. That's going to be simply equal to 25 over 49, right? Which is the exact answer, right? So now we have determined the limit as x approaches 0 of sine squared of 5x over sine squared of 7x using L'Hopital's rule, right? Which is the correct answer, 25 over 49. As you can see, that's what we found when using the fundamental trigonometric limit. So you have 2 ways of evaluating this particular limit. All right, guys, that'll be all for today. I'll see you guys next time.